have 1.3 billion people, 100,000 water systems, and 70% of our pipes have lead. These statistics represent the state of India's water quality and the extent of contamination. How many of us are absolutely sure that the water we are drinking is safe and contaminant-free? I'm Gitanjali, and I find solutions to real-world problems. My journey has been about tackling one of the main challenges we face today, access to clean drinking water. And along this journey, I developed a device that detects lead in water faster than current techniques. While my story has a whole lot of science, it speaks to something much larger: how we can collectively encourage science and technology and solve the problems in our society. It all started 2 years ago when I learned about the water crisis in the city of Flint, state of Michigan, US, where peak lead levels were detected to be around 127 parts per billion, way above the US Environmental Protection Agency standards of 15 parts per billion of lead. Surprisingly, this was not just limited to a city in mid-Michigan and its 100,000 residents. This is a worldwide problem, and we need to do something about it. Mercury, arsenic, cadmium, and lead are the top contaminants in water and are growing every day. 60% of the water in the Indo-Gangetic Basin has harmful levels of arsenic. Out of these, lead poisoning is growing at an alarming proportion. 33% of water samples from the top 26 cities in India have harmful levels of lead. Out of these, 31% fail to adhere to the World Health Organization standards of 15 parts per billion of lead, and 2% of these fail to even meet India's standards, and very lenient standards of 50 to 100 parts per billion of lead. Lead can enter our water through many channels. It can come through corroded old lead pipes, solders and pipe joints, fixtures, low-quality PVC pipes, and even brass faucets. All of these are very common to find in India. We have a big problem in our hands, and lead in water is far bigger than lead in our instant noodles. Let me tell you why this is such a big problem. Lead is harmful because of the lingering effects it has on the human body. In simple terms, lead and calcium compete for the same location within the body and are stored within the bone. So when lead is present in the system, the body substitutes it for the calcium and builds up everything with it. So the younger the child, the more impact. A child can experience birth defects or abnormal growth with harmful levels of lead in their body. Health effects of lead in water ranges anywhere from just headaches and nausea to possible seizures and even death. Lack of knowledge of contamination and the extent of contamination is the bigger problem, as it has kept people away from finding alternatives sooner and taking action. Hence, detection became my primary focus. The current solutions in countries like India or America are either cumbersome, take time, or expensive. They don't necessarily look at detection, accuracy, contamination levels together. They're either test strips, which are not accurate, or sending your water to your local water facility lab, which is inconvenient, expensive, and takes time. Unfortunately, in countries like India, there are no easy home test kits at all. My solution addresses the core issue of speedy detection of lead contamination, helping people take preventative measures and maybe even saving lives. It uses the latest developments in nanotechnology, is easy to use, fast, accurate, portable, and inexpensive. MIT and others have been working on using carbon nanotube-based sensor technology to detect hazardous gases in the air. I decided to expand this idea to apply for liquids to detect lead in water. Due to the complexity of detecting lead, Especially in a liquid medium, this required a radically different approach than current solutions in the market. Therefore, I decided to build one. I named my device Tethys, after the Greek goddess of fresh water, and it fills the gaps in the current solutions. Tethys includes 3 main parts: a core device housing a processor with a Bluetooth extension and a 9-volt power source, a disposable cartridge that attaches to the core device and forms a circuit with a processor. Due to the nature of my medium, liquids, I had to use a bucky paper form of carbon nanotube so it wouldn't easily disperse in the water. And lastly, a smartphone that connects over Bluetooth to display results. The working of this device is quite simple. This disposable lead sensor cartridge here includes carbon nanotubes specially treated with chloride ions. Let's say the water here has lead in it. When I dip this into the water I want to test, the lead in the water binds with the chloride ions in the nanotube, forming lead chloride molecules, increasing the amount of resistance to the flow of current, as well as decreasing the conductivity. The conductivity drop is correlated to the severity of the lead compounds in water. To make it easier for the user, I added an Arduino processor to measure all resistance and current values, and a Bluetooth extension so we can send all the data to your mobile phone in the form of either safe, slightly contaminated, or critical. The results show up almost instantaneously on your smartphone on an easy-to-read visual scale. At an R&D or prototype cost, my device costs about 1,300 rupees, and the cartridge costs close to 275 rupees. At scale, I hope to bring the entire device cost down to 300 rupees and the cartridge to only 10. I'm currently working on evolving my device even further, and I also received investment funding. I'm happy to unveil to you the latest version of my device. It is more compact and has better sensor usability. I'm also planning on refining the carbon nanotube sensor to make sure it's more accurate, performing false positive tests, trying with other dopants such as fluorine and iodine, and even in the future, adding the option to crowdsource device data. Scale testing continues to be a primary focus, and I hope to partner with various research labs and water facilities in the future in order to perform tests. I believe that the purpose of science is to make a difference. Unfortunately, statistically, there are not many girls in the science and technology field. And I wouldn't be here without the support and guidance I received along the way. Science needs all available hands and intellects to come together and solve the problems of today and tomorrow. It needs all of us. We need to come together and take action. I am glad that my fellow speakers are speaking about this, and I'm trying to do my part in speaking at various forums like these and seeking help from as well as seeking help from not only industry leaders, but also lawmakers, as you can see here. I believe that we should aspire to solve bigger problems. I'm 12, and I want to make a difference. The invention of my device was motivated by a problem that I'm very passionate about solving. If I could request one thing from each of you, it would be to seek a mentee and mentor them in the areas that they are passionate about. We can spread awareness in our community about these issues by raising funds, promoting science and technology, especially for girls, in rural India, encouraging aspiring problem solvers and volunteering our time. Paraphrasing a quote from my favorite scientist, Marie Curie, "We have come such a long way, but we still have so much more to do when we look ahead." If we all recognize and alleviate the problems that our fellow citizens face, we can make the world a better place. Thank you. Thank you.